Okay, good day to all of you. So we're already in chapter 5, Arduino IDE. Actually, this chapter will be the start of how are we going to code using the Arduino IDE. So that's the title of our chapter for today. So let's delve, what is this Arduino IDE? Let's start. So in this chapter, you will learn what an Arduino sketch is, what the Arduino IDE is, what the Arduino web editor is, and how to write your first sketch. So, what is this sketch or the Arduino sketch? So, is this sketch the one that we commonly know as the drawing? So, actually, it's different. So, when we program the Arduino, the code is put into a project. So these projects are called sketches, and a sketch is stored in a sketchbook. Okay, so this sketch is coined by Arduino. So this will be a unique or a distinguished term. Actually, this is just meaning Arduino code, the code of an Arduino program. They just use it so that if you say sketch and an Arduino, it will really easily identify that it is a code for the Arduino boards. And then the coding language used to program the Arduino is very similar to the C programming language. So it has a very similar um, syntax rules and semantics to the C programming language. C programming is a very old programming language, as actually we are using, when I was in college, we used the C programming language in all of our computer science courses. So you can imagine it is really very old. So before a sketch can be uploaded to an Arduino, the Arduino IDE or web editor must go through several steps to build the application. So before we have this term uploaded, so how can the sketch be uploaded to the Arduino? Is it really this sketch that is uploaded to Arduino, or it will go through a process, and then the uh, end product of this process is this the one that will be uploaded to the board? So let's see. So the first step to building a sketch is to perform some pre-processing, which turns the sketch into a C++ program, which is passed to the compiler to turn this human-readable C++ code. So this human-readable C++ code, this is our sketch. And then this will be converted into machine-readable instruction by the use of compiler. So this machine-readable instruction, this is commonly known as the object file. And then these object files are then linked against the standard Arduino libraries that provide the basic functionality for the Arduino. And then the results of linking the object files and the standard Arduino library is a single hex file, and then this single hex file can be uploaded to the Arduino and run. Okay, for us, actually, what we're doing, the code or the Arduino sketch, we are using our own language, our own alphabet. But this code or Arduino sketch, this cannot be uploaded directly to the Arduino board because the Arduino board cannot understand this human readable C++ code. So in order for the Arduino board to understand this human readable code, you need to compile it, and then after compiling it, it will produce a machine readable instruction which is called an object file. And then this object file is paired or linked to the standard Arduino libraries. Then after linking the object file to these standard libraries, the result will produce this single hex file. And then this single hex file, the question is, do us humans or programmers can read the hex file? No, actually this is already a code or a language that the Arduino board has understanding. So that's why if you upload it to it, so Arduino will process and of course will execute it. And of course the term is run. So Arduino Sketch is the project that contains the human readable code. So that's why I'm saying as programmers we are coding that can be built and uploaded to an Arduino. So the Arduino IDE. So what is Arduino IDE? So IDE, the meaning of IDE is Integrated Development Environment. So IDE is a common term for programming. It is where you code a specific application. For example, there's an IDE for Arduino, there's an IDE for Turbo C, there's an IDE for Visual Studio. There are actually corresponding IDE to a particular programming language. And then it can be installed locally on Windows, Mac OS, and Linux-based computers. So you can install it standalone. It does not need an internet connection for if you're going to install the Arduino IDE. So this is very suitable if you don't need an internet, if you don't have an internet connection, it will still run compared to the um, present or current applications that for it to run specifically for applications on your smartphone, that there are many online apps compared to offline apps. So you can consider Arduino IDE as an offline application. So this is the site where you can download the Arduino IDE. And this is an official Arduino IDE and it is free. But you have an option to donate, but then again, you can also have the option not to donate if you really don't have any money and you just want to download the IDE. So, this is what the Arduino IDE looks like. So, on Mac OS, this is the interface. On Windows, this is the interface. And then for Linux, this is also the interface. So, we can conclude that disregarding the operating system platform that you are using, Arduino IDE does not change its interface. It is just the same. It only differs, example, for the window menu because, of course, this is the window menu for Mac OS, this is for Windows, and this is for Linux. Okay, let's explore the IDE. So the menu bar for the IDE functions like a menu bar in other applications, where you click on one of the options and a submenu appears with more options. So if you are familiar with Windows applications such as Word, PowerPoint, so you already have encountered this menu bar. And then the command bar provides quick access to 5 of the most commonly used commands. From left to right, we have verify, upload, new, open, and save. Okay, what is the verify command? So the verify command will attempt to compile the sketch in order to verify that there's nothing wrong with the code. Actually, for verify, for others, it is in old programming language. This is used as the term is compile, but then for Arduino specifically, it is to verify. It is to check if your Arduino sketch is free from syntax errors. Okay. Um, One tip to avoid syntax errors in Arduino IDE, you must really imitate the code. If it is capital letter, make it capital letter. And how it is written, actually, that's the secret. So it's not actually like the syntax rules of a programming language is very strict, not just for us humans. For example, for us, A and small letter A and capital letter A is basically just the same. But for Arduino, which is patterned uh, from C programming language, the syntax is very strict. So there is a difference for a small and a capital letter. So you really must follow the syntax rules for the Arduino IDE. And then next is we have the upload command. Will attempt to build and upload the sketch to the attached Arduino. So what's the difference between verify and upload? The the difference is that upload command, it compiles and upload the sketch to the Arduino. It will successfully upload the Arduino sketch if there are no errors in your code. So verify, you're just going to compile or check if there is an error for your there's an error inside your Arduino sketch, but upload command, this will compile and this will also upload successfully if there is no error in your Arduino sketch. And then next, the new command will create a new sketch, of course. The open command will open a sketch, and then the save command will save the sketch. So this is a very important rule that you must remember. In order to upload a sketch, you must have an Arduino connected to the computer you are working on and configured in the IDE. Otherwise, you will receive an error. So this is very important. Before you upload a sketch, make sure first the Arduino is connected to the computer you are working on and configured in the IDE. So that's very important. The question is, what if I'm going to upload a sketch without an Arduino connected to the computer? The problem is, the Arduino IDE will look for the board. Where's the board? Where's the board? Since it's not connected, it will be displayed in the status area that the Arduino IDE cannot find the Arduino board if it is really connected. And then what if you still you connected the Arduino board, but then you did not properly configure it in the IDE? It's just as similar as to not connecting the Arduino at all, because the result is the Arduino IDE can still find the connected Arduino board. So you have to, again, connect the Arduino board on the computer you're working on and configure it in the IDE. So these are the parts of the Arduino IDE. So the menu bar is composed of File, Edit, Sketch, Tools, and Help. And then if you're going to click this menu, it will appear a sub-menu for it. And the next is we have the command bar. So these are the icons. This is the icon for verify. So this is the icon for upload. And then this is the icon for new. This is the icon for open. And this is the icon for save. Okay? For the first time, if you're going to open or you're going to have a new Arduino sketch, automatically it will provide a file name. This is automatically provided but you can still edit the file name if you want to, describing your project. So this is a very generic. So we have sketch and then underscore, then it will automatically indicate what date have you made the sketch. Okay, that's the date. For example, today is November 18. Okay, next is what we have here in the coding area is we have the two function. Okay, we call these functions in the programming. If you have an open and close parenthesis, a word with an open and close parenthesis, automatically it is a function. So these two function, we have void setup and void loop. So void setup, void meaning in programming, so I already have a little discussion for this. Void means setup function will not return any value. So that's the meaning of void. And then since this is a block, programming block or a function, you have to have this pair of curly brackets. Okay, this is a typical example of a student or a programmer why he or she commits an error, because sometimes for functions or for a block, they are forgetting that curly brackets must be paired. We have open and closed curly brackets. So next is we have this line. So we have double forward slash. Put your setup code here to run once. So if you put a double forward slash before any statement, Arduino IDE will consider this statement or these words or this collection of words as comments. Comments, Arduino IDE will ignore whatever is after this double forward slash. Comments are used specifically for programmers. Actually, it is a very good programming practice to put comments in your Arduino sketch or in any code. Why? Because what if you have other programmers you are collaborating with, and by putting comments, it is easier for them to understand what is the functionality of this particular block or particular function. So it's very helpful, not just for you, but also for your collaborators, that you have to put comments. It's a very good programming practice. And then, so as you can see in the meaning of void setup, you can put here and your setup code here to run once. It means that anything that you put inside this paired curly brackets will only be run once. So code void setup is used for declaring variables, or again for functionalities that needs to run only once. So you have to put here in the void setup. So we have another function. We have also void loop. Again, void, meaning a loop function will not return any value. So what is the description of the loop based on the comment? Put your main code here to run repeatedly. So that's why it is called loop. Meaning, if you put a functionality here or your main code here, it will be repeated as long as the Arduino board is running. So that's the meaning of void loop. So these two, the question again, ma'am, do we need to type the void setup and void loop? No. For the ease of use of the Arduino IDE, if you're going to create a new Arduino sketch, this is already automatically indicated for any new sketch that you are doing. You don't need to type. What you're going to be concerned with is the contents of the void setup and the void loop. So this is the content of the coding area. And then what is this status area? This status area, it shows the activity of your Arduino IDE. If it is compiling, if it is uploading, it is shown here. And then if there is also an error, it will also be indicated in here. So for errors class, you need to have an understanding. You need to understand, you need to read, okay, and understand where is the error coming from. And then we have another indicator. This is also very important. Not just it's not just mentioned in here. If your Arduino or Arduino board is properly configured, it will appear on this lower part, lower right part. Arduino slash Genuino Uno on COM1. It also be indicated that that it is connected in COM1 port. Okay, maybe you have another question or notice, ma'am, what is Genuino? Genuino actually is just another name for Arduino. Actually, when I read the article, there is a dispute for the distribution of Arduino. If I'm not mistaken, the name Arduino must only be used in, I don't know, US or Italy. Then Genuino, if it is an international release, you have to use Genuino. But as you can see, I already bought an Arduino starter kit, an original one, but I bought it and it's an Arduino, it's not Genuino. So actually that's the issue right here. But then Genuino is just the same with Arduino. They just used another name for it. Okay, next is we have for continuation for exploring the IDE. So the coding area is where we write the code for the Arduino. You will notice that when we start a new sketch, two functions, setup and loop, are automatically created in the main tab, as I've already discussed with you. And then next, the status area is used by the IDE to let us know what is happening when the IDE is doing something like compiling, uploading, or verifying a sketch. So that's that is the use of the status areas I've already discussed. And in addition to it, It will also display what type of error that you are having. And then in order to upload a sketch to an Arduino, again, it is very important. We need to connect the Arduino to the computer the IDE is running on with a USB cable and configure it in the IDE, as I've already mentioned in the previous slide. And then configuring the Arduino within the IDE requires us to tell what type of Arduino we are using and what port it is on. Okay, for configuring the Arduino board, because of many Arduino boards that are existing, you need to specifically select what type of Arduino board that you have or what you are using. And then where is it connected? What communication port? So you also have to know that. So, configuring the Arduino within the IDE. So, to connect an Arduino to the IDE, the first thing the IDE needs to know is what type of Arduino is being used. To do this, we click on the Tools options in the menu bar and select the Board option. Okay, so first is you need to identify what type of Arduino board you are using. You have to be very specific because if you selected a wrong board on the Arduino IDE and then you have a different board, it may run, but definitely there would be incompatibilities because of course they have a different they have a specific libraries for a particular board. So for a safe, I never tried it. Wrong board that is in the Arduino IDE, and then there are different boards, but don't just test it. Maybe there's an effect for if there is an miscalculation or um, not really indicating the real board. It's better to identify the board. That's it. And then once the board is selected, the next thing that the IDE needs to know is what port the Arduino is connected to. To select the port, click on the Tools menu option from the menu bar and then select the port option. Okay, actually this tools option, this is a Microsoft Mac OS platform. So it's a different menu. But then the contents are just the same. This is the content of the tools menu. Actually, you don't need to know all the functionalities of this in the tools menu. Actually, what you're concerned as beginner for programming is the serial monitor, and then the board, and then of course the port. So again, for you to configure the board, you have to click the board, and then a list of all the Arduino boards that are existing in the market are here. And then since we are using Arduino Uno for our course, so let's select Arduino Genuino Uno. Maybe there's a question, ma'am, what if I have a clone version and not the Arduino? Actually, it does not matter to the Arduino IDE. It is still identified as an Arduino or Genuino Uno. And then again, because it has so many boards existing, you have to select the proper board that you have. If it's really Uno that you have, then you have to select Genuino Uno, and then if you have Nano, then it's Nano. Okay, do not experiment. Of course, there will be an error, so you have to really select the proper board. And then next, after configuring the board, is next you have to identify the port. So click. So this is the interface for Mac OS. It's actually different in Windows. So I will provide additional tutorials for this one. So you have to select here. Actually, this is very obvious because as you can see, the serial ports that are available, first is Bluetooth and wireless IAP and um, John Hoffman's phone. So actually, the iPhone. So obviously, this is not these selections are not the one for Arduino. So it's indicated here the Arduino or Genuino Uno. Okay, so you have to select it. And then you will probably have a different list of ports. However, it is usually obvious which port should be selected because it displays the name of the board attached to a port if it sees the board. So most of the time, the IDE will automatically select the correct port for you. So once the board and port are selected, the IDE is ready to upload and compiled sketch to the board. Okay, there's only a little problem. There will be no problem if you only connected one Arduino board. So that will be not be a problem. What if you connected to your computer at least two or three more Arduino boards? So actually there is an advanced way to properly configure to make sure that the port that the Arduino board that is connected, you can see which port is which port that this Arduino board is using by using the control panel. So again, I will provide a separate video tutorial on how to do this one. So next is we have the Arduino web editor. So the Arduino web editor enables us to create and upload sketches within most web browsers. So Arduino web editor is the online version of the Arduino IDE. So you need an internet connection for you to access the Arduino web editor. It also works also to for the web browsers of your smartphones. And officially, the web editor is supported with the Chrome, Firefox, Safari, and Edge browsers with the installation of a plugin. So this is the link for you to go to the Arduino web editor. So before you can install the plugin and use the web editor, you will need to create a free Arduino account. Actually, using a web editor is free, but you have to create first a free Arduino account. Once we are logged into our account, the site will walk you through installing the plugin. So this is the content of the site for create.arduino.cc, but the interface or the what the page looks like changes depending, of course. Actually this screenshot is from last year, so you may expect that the create.arduino.cc, if you're going to explore it later on, it may not look like this anymore because this screenshot is still last year. But then the functionalities of the page are just the same. We still have the Arduino web editor, but since it's already 1 year after, maybe there are other features on the Arduino Create. So if you're going to click Arduino web editor, you will be going to the next web page. So log in, of course, if you already have an existing account, Arduino account. And then if you do not have yet an Arduino account, of course, you need to create a new account. Or you could use your existing Google or recommended your institutional email address. As I've said, if you're signing in using your school's or university's email address, most of the companies have this freebies or have discounts, or they make features free for students. So it's better to create an account, use the university domain email address. Okay, so this is what the Arduino web editor looks like. So there are, of course, a little difference in the interface, but then the functionality and the commands are just the same. But of course, there is exclusive for the web editor, and there's also exclusive for the IDE. So let's explore the Arduino web editor. So the menu bar, like the Arduino IDE of the web editor, enables us to quickly access certain items like examples, libraries, and the serial monitor. Just the same with the Arduino IDE. Arduino IDE also has examples, libraries, and serial monitor. So next, the command bar provides quick access to commonly used commands and gives us the ability to select the board we are using. So the command bar, as you can remember for Arduino IDE, it only has the verify, upload, new, open, and save. But for command bar, you can already access here the ability to select the board that we are using. And then the icon with the check mark, as you can remember, it is the verify command button, or will verify the sketch, while the icon with the arrow compiles and uploads the sketch for the Arduino. So that is the upload icon or button. And then the icon with three dots opens up a menu that enables us to save, rename, download, and delete the current sketch. So this is, again, let's go back to the Arduino web editor. So for the editor, so this is the menu bar. It is composed of the sketchbook, examples, libraries, monitor, and then the help, and then preferences. And then the command bar, it is said that it has the verify and the upload, and you can the first difference is you can already select the board or port here instead of going to tools. So Arduino IDE has tools menu, but here there are no tools menu that you can see. And then we have three dots. For three dots that's described in the previous slide, we have you can save, rename, or delete the sketch. And then we also have share, since this is an online version, you can share it. And then for coding area, so just the same, it automatically provides the void setup and void loop. And then we also have the status area where you can see the activity of the Arduino IDE, and also the type of errors that you will encounter while coding. Okay, so again, the coding area is where we write the code for the Arduino, just the same with the Arduino IDE. As with the Arduino IDE, you will notice that the setup and loop functions were automatically created when a new sketch is created, just the same. And then the status area is used by the IDE to let us know what is happening when the IDE is doing something like compiling, uploading, or verifying a sketch. It's just the same. The status area of the IDE in the web editor has just the same functionality. Okay, next is how are we going to configure the Arduino within the web editor. So in order to upload a sketch to an Arduino, we need to connect the Arduino to the computer the web editor is running on with a USB cable. Okay, so though this is an online version, you still need the actual Arduino board to be connected to the computer where the editor is running with a USB cable. So, if you're going to ask, is it the same with Tinkercad that it has a simulator? Currently, it does not have a simulator yet inside the web editor. So that's the only downside. Even though that this is already online, so the purpose of Arduino web editor is you can program on the go. You can program if you have an internet connection. That's a very important condition. You must have an internet connection in your area if you're going to use this Arduino web editor, and you must also have the actual Arduino board with you. After the Arduino is connected to the computer, we can select the Arduino and port within the web editor by clicking on the select board or port option in the command bar, as you can see in the previous slides with the Arduino web editor interface. If the web editor recognizes the Arduino board, you should see the Arduino board and port listed in the drop-down menu. So, this is one that we are saying, the select the board and port. So, if it is connected and recognized by the web editor, if you connected the Arduino to a USB interface, and then it will automatically be connected here. Again, this computer is a Mac OS. So let's look if what is the interface if we are using Windows operating system. So next, if you see the Arduino, select it, and you will then be able to upload compiled sketches to it. And then the best way to learn the Arduino IDE or web editor is to use it, of course. Um, this lecture or this lesson will be useless if you're just going to watch. A very good teacher, or a very good teacher specifically for this time of pandemic, is you have to use it and explore. So gone are the days that you will be taught of how to use this application step by step, menu per menu, command per command. But no, it's not the case anymore. You have to explore, because that at your own pace, because that's the only way that you can learn, because it's easier to learn based on experience. So I encourage you not just to watch or remember things because you have seen it. There's a better reinforcement for learning is you have to explore and actually use it. So what are these examples? As you can see in the Arduino web editor, in the menu bar, specifically there are examples. Actually, in the Arduino IDE, there are also examples there. So there are numerous examples that are included with the Arduino IDE in the web editor. So these examples are simple sketches that demonstrate the Arduino commands and how to use them. So these examples range from the very basic sketches that demonstrate how to read and write digital input-output or I/O to more advanced sketches that show how to use sensors. So while these examples are designed to demonstrate the Arduino commands, they can also be used as examples of how to write good code for the Arduino. So we have these examples for you to explore. The basic commands of the Arduino are advanced sketches for Arduino for a particular sensor. So to access the examples within the Arduino IDE, click on the File option in the menu bar and then go to the Examples option. If you go to any of the categories, you will see a list of examples for that categories. If you select an example, such as the digital read serial example under the Basics category, the code for the example will load in a new window in the sketch. So this is for the File option, and then go to Examples, and then it is already listed here, the built-in example. Example, if you're going to select Basics, okay, for this is for the built-in example, examples for any board, and then examples for Arduino or Genuino Uno, and examples from custom libraries. There are many examples. What if, for example, you need a code? Sometimes you can already reuse the code that is there is indicated here, and it's not bad to copy. Why are you going to tire yourself of thinking of the code if it is already existing? We have this term, reusing of code. It's not bad. For example, if you're going to integrate it into your project, okay, it's not bad to reuse a code. Okay, so if we want to open the digital read serial from the built-in example, so it is said here what you're going to learn is a good programming practice, because as I've said, you can use because they're using comments. So for example, this one, int push button is equals to 2. So int is an integer. This push button returns a value of integer. Later on, we're going to discuss what are these void integer, but I just gave you an overview of these data types. So what is the meaning of int push button is equals to 2? Digital pin 2 has a push button attached to it. Give it a name. So you put a name of, or this description of push button. So by means of, again, of comments, you can have an understanding of what is the purpose of this particular function or this particular line of code. Okay, another symbol for comment is this one. This double forward slash is used for one-liner comment. But if you want to use comments that has two or more, you're going to use two or more lines. Instead of going, you could put double forward slash on each of the, if you're going to put a forward slash for each of the line, it will be very tiresome. What if your comments are 1,000 lines of code? So you're going to write double forward slash for 1,000 of them? No, you just need to enclose them with forward slash asterisk, and then a pair. So first is the forward slash and then the asterisk, but the end you must put first the asterisk and the forward slash. So that would be the this is also a comment for two-liner or more comments, so that you'll not tire yourselves of putting double slash. Okay, we have next. Okay, with the web editor, so how is it different with the examples in the web editor? So that to load an example, select the examples option from the menu bar. So as with the Arduino IDE, we will see the same list of example categories. Then we can then select any of the categories to see the list of examples. What makes the example in the web editor different from the examples in the Arduino IDE is that most of the examples in the web editor also include layout. So that's the difference, the main difference. The examples in the web editor has the layout or the circuit diagram and schematic diagram showing how to create a circuit that can be used with the example. So that's the difference between the two. So this is the interface if you want to look for examples, the built-in examples as what you have seen in the Arduino editor. So click examples and then we have the built-in. As stated, examples in the web editor is just the same with the Arduino IDE except that that's the difference. There is a schematic and layout for that particular code or sketch and then the implementation in the board. The Arduino IDE doesn't have this feature. Okay, next is we have the Arduino libraries. Like most development platforms, the Arduino environment can be extended with libraries. So these libraries provide extra functionality that we can use in our sketches, such as providing access to specific hardware, manipulating data, and adding extra features like a task scheduler by using the Arduino cron library. There are numerous libraries that are built into the IDE and web editor, but we can also download other libraries or build our own. Actually, if you're already an advanced programmer, you can build your own library if you can. Or you can also download other libraries. Example, I have this experience of using Arduino. I use this special or a temperature sensor that uses a separate library. If you won't copy or install the library inside the Arduino IDE, the temperature sensor that I used will not be recognized. So library is very important for the Arduino IDE to recognize this particular sensor or particular output. So that's the importance of providing libraries for your projects. To access the libraries in the Arduino IDE, we select the Sketch option from the menu bar and then select the Include Library option. This will show another menu that lets you load a library or manage libraries. If you select any of the built-in libraries, the header files will automatically be included in your sketch. So this one, for example, for the library, just select manage or add zip library, and then there are also lists of libraries that are included. So these libraries are again, you need it if you will going to use a particular device or a particular sensor or output that the Arduino IDE doesn't have. So you need to have a library for it. And then selecting the Manage Libraries option enables us to download and install other libraries that are not included with the standard installation of the Arduino IDE. So that's the function of Manage Libraries. Again, you can download and install other libraries that are not included in the installation of the Arduino IDE. So when a library is downloaded and installed, it will then appear in the quick list of Arduino libraries and can be used just like the built-in libraries. So again, if you already downloaded and installed, it will be included in the list of built-in libraries. And then a number of these libraries also install example code that can be accessed from the example section of the IDE. So these inventors or the programmers who created libraries are very generous. Actually, for Arduino, the programmers here are very generous. Since this is an open source platform, they really have this mindset of being open, share what you know. So that's a very good initiative in the Arduino. So to access the libraries in the web editor, so select the library option from the menu bar, and a list of available libraries with a search bar will appear to the right of the menu bar. There are hundreds of libraries included within the web editor. This makes accessing the libraries easier than with the Arduino IDE because we do not need to install them. So that's very good with the Arduino web editor. Because why is it limited to the Arduino IDE? Of course, if we're going to include these hundreds of libraries in the Arduino IDE, then the Arduino IDE installation or the size of the file or the executable file is very big. So that's why it's just limited to the basic functionalities. But in web editor, since you're not installing the libraries there, so you can say actually we can conclude it here that web editor has more libraries than the standard or the standalone Arduino IDE software. Okay, for the menu bar of the web editor, select libraries, and then we can already search libraries that you want. For example, you want to have a library for your temperature sensor or for your, for example, Bluetooth device. So this you just need to search it. Okay, the web editor also makes it easier to share sketches that require libraries. When sharing a sketch that was created with the Arduino IDE, the person that receives a sketch needs to install the correct versions of the required libraries. This can occasionally become complicated and confusing. So, example, if we want to share our our sketch to our collaborators or to our group mates, if you're using Arduino IDE, you need to make sure that the version of the Arduino IDE he or she is using is just the same with you, because there is also compatibility issues if you are using different versions of the Arduino IDE. But that is the advantage of the Arduino web editor. And then with the web editor, when we share a sketch, the web editor will ensure that the correct libraries are used when the sketch is compiled. So again, Arduino is promoting the advantage of using the web editor. So to add a library to a sketch, search for the library from within the search bar, and when the library appears in the list, hover the mouse over it and an include button will appear. So click on the include button and the required headers will appear in the code and the library will be included in the sketch. So this one, for example, you've searched the library, search here, and what you're looking for is for Atmel AVR explained mini, so mini package. So this is the, for example, this is the one that you are looking for, and then if you're going, then you have to include you have to click include. Okay, so we are already finished with the interfaces of the Arduino IDE and the Arduino web editor. Then we'll go to the next important part of the Arduino IDE and the web editor, and this is called the serial monitor. So the serial monitor sends and or receive text, usually through the USB cable. This enables us to receive debug messages or send text from the keyboard within the web editor or the Arduino IDE. To use the serial monitor with the Arduino IDE or with the web editor, you must first connect an Arduino to the computer and establish communication between the Arduino and the IDE or the editor. So again, to use serial monitor, you have to make sure that the Arduino is connected and properly configured in the computer or in the computer that you are using, where the Arduino IDE and editor is there. And then to begin using the serial monitor within the Arduino IDE, click on the serial monitor icon in the upper right-hand corner of the IDE. So this one, this is the icon for the serial monitor. Okay, this is the interface of the serial monitor. So we have the input section, and then we also have the output section. Okay, we have auto scroll, meaning if this whole output section is filled with text, it will automatically scroll and then it will not wait for the user. And then we have this new line, 9600 baud rate. We're going to discuss the baud rate. And then if you want to clear the text in the output section, you can click the output. Okay, new line if you want, this new line, let's turn here. New line if you want that every text is starting a new line. So that's the term, that's the function of that. So the input section enables us to send text to the Arduino. So that's the purpose of the input section. To do this, type the text into the input box and click the send button or hit enter to send it. But to do this, you have to have a specific code for the Arduino to accept the input. So the text from the Arduino will appear in the output section. Once you press send, any text that you have typed from the input section will be displayed or appear in the output section. So to use the serial monitor with the web editor, click on the monitor option in the menu bar and the serial monitor will appear to the right of the menu bar. Let's look how does the serial monitor looks like in the Arduino web editor. So this will be the serial monitor. So from the menu bar, we have click monitor and uh, just the same. You have this new line and then the baud rate and then the input section and also the output section and then auto scroll. The only difference is that it has disconnect button. Okay, just like the serial monitor in the Arduino IDE, to send text to the Arduino, type into the input box within the input section and then click on the send button or press enter to send it. And then just like again, as stated, the output from the Arduino will appear in the output section. So let's have this example. We have this hello world. So hello world is a very, it is already a tradition for programmers, for first-time programmers. Hello World, it is used by the, I'm sorry, I forgot who the programmer is. It's his first line of code, and he always uses Hello World. So Hello World is really used by first-time programmers. This is the tradition. So we're going to use Hello World. Okay. So Hello World actually is used in Turbo C, but you can also do it in Arduino IDE. So the setup function is run once and only once when the application first starts. As you can remember the description of the setup function. As I also remember, if you could also remember what I've said, that if you put a code inside the setup function, it will only run once. Run once and only once when the application first starts. So this function enables us to initiate any variable. So that's why if you're going to declare any variables, put it inside the void setup or hardware when the application first starts. After the setup function completes, the loop function is then called for the first time. So it's always the order. It's first the setup function and then next is the loop function. So when the loop function finishes, it will be called again and will continue to loop until the Arduino is powered down. If you can remember my discussion with the loop function, this is what I already said, that because it's loop, it will continue to run over and over again until Arduino is powered down or off or no power supply at all. So, to create a new sketch with the Arduino IDE, we can use the new icon on the command bar or select File, then New from the menu bar. To create a new sketch with the Web IDE or Web Editor, click on the Sketchbook option from the menu bar and then click on the New Sketch button. So, this is our first code. So, once a new sketch is created, add the following code to the setup function. Specifically, you have to put this inside the setup function, inside the pair curly brackets. Okay, so we have serial.begin, then open and close parenthesis 9,600. So, we're calling the serial monitor function for this, serial.begin. This is the baud rate that we're going to use for displaying the text. So, serial.begin. As I've said, if you're going to type the code per line, you must imitate it. Since serial is capital letter S, you have to make it capital letter S. Ma'am, what if we do not follow? We want it to be this S to be small letter. Then you will have an error. And then begin B is a small letter. If you really want to make it capital B, again you will have an error. Okay, so serial.begin 9,600. Okay, as you could notice, we have this semicolon. Semicolon in us, this acts as the end of the sentence. So semicolon is like a period for our sentences. So if, again, a question, Mom, what if you forgot this semicolon? Again, you will have an error that describing that there is no semicolon, because this is meaning this is the end of a line of code for the programming language. So mostly actually, semicolon is standard for most of the programming languages because it always ends in a semicolon. And then next is we have serial.println. So again, capital letter S, then println. Println means print line. You have to print one line, and then, okay, what does println needs? It needs a string. String meaning a word, a group of words, a single word, a collection of letters, spaces, numbers, and then you must enclose it with double quotation marks. Again, if you have a question, Mom, what if we forget the double quotation marks? Again, you will have an error. So, to avoid committing errors, you have to follow or you have to type the code as it is. Okay? So, hello world. And then again, end the line with a semicolon. Okay? And then again, type it inside the setup function. Okay, we will then need to connect an Arduino to the computer and establish a connection between the Arduino and the IDE or web editor. But you can also do it in advance so that you will not have a problem. You've already typed the code and then actually there's no problem if you will do it later or do the configuring of the Arduino to the computer later or earlier. There's no problem. And then we can then run the sketch by using the upload button at the command bar for both the Arduino IDE and the web editor. Okay, so if you're going to run the Arduino sketch, it will only be displayed, the hello world will only be displayed once in the output section because you put it in the setup function, because it is said that if you put any code there, it means it will only be run once. So you only see one hello world in the output section in the serial monitor. So what if we want to not just display one line of hello world, but we want to put succeeding lines? So this is the another modification of the hello world. So now let's remove the serial.println open and close parenthesis hello world semicolon line from the setup function and put it in the loop function so our code looks like this. Okay, so we have this one. Instead of the serial print ln is with the serial that begin 9600, put this code inside the void loop. So what do you expect the results here? Since the loop function means if you're going to put any code there, it will run continuously until the Arduino is off. Okay, so let's see. So this will be the output. Again, if we had the original code for the hello world, it will only display one hello world, one line. Then this other lines will not be included. Okay? But since we have modified, we already modified the hello world and put it in the loop, so this is the output. So this is the output of our sample program. Again, I will provide an actual video tutorial so that you can visualize, or actually you can try it on your own if you can already. So, okay, next we have another example sketch. So we have an echo application will read the text in from the serial monitor and will then output it back. So the difference with the first example that we have done is that string is included in the program or in the Arduino sketch, the hello world. We really indicated it inside the code. For this example, for echo, um, we will be needing an actual user input string. And then whatever the user type, it will then appear in the serial monitor in the output section. Okay. The text will be entered into the input field and the text will be echoed. So that's the meaning. So that's why it's echo. Okay, we have an example here. If we're going to type in the input section, example, hello from me, actually you can put anything, even in our own Tagalog language, you can do it. And then once you press send, it will be reflected in the output section. So how are we going to do it? This is the code. As I've said, ma'am, can we do it even without the code? No, as I've said in the previous slides that you can only do the getting the user input and then appearing it in the output section if okay, so we have bytes in, we have to declare a variable. So bytes in is the name and then it's a data type byte. So it's composed of 8 bits based on the computer. And then since we're going to use a serial monitor, so again, let's put serial that begin 9600. This is the standard baud rate. Okay, 9600. Okay, then for the void loop, okay, let's discuss one by one. If serial dot available, what does this code mean or line of code? Meaning, serial dot available if the user typed a string in the input section. So if serial dot available is equal to 1, that's the meaning of that. That if there is an input text from the user, then it will be read. It will be read. So that's why serial dot read and then open and close parentheses. So this serial dot available and serial dot read, these are function. Okay, whatever the serial dot read has read the input string, okay, it will be stored in bytes in, the one that we declared on the upper part of the Arduino sketch. So class, it's a very different concept. It's not the usual. For example, bytes in is equal to serial read. The content of bytes in will be reflected to serial read. No, in computer, it's in a reverse order. So again, let me explain. Whatever the data that the serial read has read in the input section of the serial monitor, it will be stored inside bytes in. Okay? And then, this bytes in, this will be used by serial.write. So, serial.write, and then it is a function, it needs the variable where the input string is stored. So, that's it in the bytes in. Okay, so that's why this serial.write, this will cause to display the input string in the output section. Okay. Maybe there's a question, ma'am, why haven't we used the println? Okay, the difference between using serial write and println is used in a layman's term. Println is used if the string is included in the code. Serial write is used when the input string is coming from actual input string is coming from the user. You're not hard coding. The term is hard coding. Hard coding means for println, hello world is hard coded in the code. It's already indicated there. For this example, for the echo, we did not indicate any actual input string here. We do not include any sentence. What we're going to input here or output or display is the actual user input from the input section of the serial monitor. So that's why we're going to use serial write. Okay, so serial write is used for this purpose, not print ln. Okay, so within the loop function, we use the serial.available function to see if there is any data stored in the serial queue, as I've already described. That serial.available, it will always check if there is an input string that is indicated and then press send. Okay, the serial.available function returns the number of bytes available for reading in the serial receive buffer. So serial available, since it returns the number of bytes available for reading in the serial receive buffer, since bytes, the data type that you have to use is also bytes. That's why in the previous code, the data type must be byte. So, it must be compatible, okay, from the serial availables preferred data type. And then, if there are bytes available to read, since, for example, hello from me is there, the code then uses the read function to read the bytes and then uses the write function to write the bytes back to the serial monitor. So, I've already explained the difference between write and println in a layman's term, but then let me read the difference between the two. So, the difference between the write function used in this code and the println function used in the previous example is that the println function will print the data as human readable ASCII text, while the write function will write the data as bytes. So, again, another explanation is that because println, the string that it is displaying is hard-coded in the sketch, while the serial.write, you need to wait for the actual input string by the user. Okay, so for the summary, set up the Arduino IDE in the web editor, learn the basic functionality of both, use the serial monitor to send and receive data to and from the Arduino. So, have you learned something new about this chapter? So, I hope again for using Arduino, as I've said, is the best teacher or the best way to learn is you must use them. It is not enough that you're going to watch Arduino tutorials without doing it on your own. Because again, experience are best teachers. So again, if you don't have any questions, or if you do have questions, you can comment. And then if you don't have, so thank you very much for listening and please like my page and subscribe. So again, thank you very much and good day.